Hello and welcome to laboratory exercise of preparation and characterizations of the nanofibers. In this laboratory exercise, we will prepare a polymer solution for electrospinning process. In electrospinning process, we will prepare the nanofibers. After the preparing of the nanofibers, we will characterize them under the scanning electron microscope. So stay tuned. Before starting working with chemicals, of course, safety first. There are some protection equipment we have to wear or use while we are working with those chemicals, solvent and polymers. So, first of all, we have to wear our laboratory coats. And secondly, there are some gloves that protects you from the exposure of the solvents and the polymer. We have to wear them as well. To protect ourselves from the splash of the solvent, chemicals or other ingredients, we need to wear a safety goggle. Or if you use really harsh or strong chemicals, we have to wear this full face mask. This full face mask will protect of your full face and also from the evaporations of the strong chemical. Today we will prepare only polyvinyl butyral polymer solution. This polymer can dissolve in various solvents, but today we will use ethanol. As I mentioned, we have polyvinyl butyral polymer and ethanol solvent, and we will use small glass tube and beakers and some measuring stuff. So first thing first, we need to weigh our polyvinyl butyral polymer. Today I'm going to prepare 10% of polyvinyl butyral solution. That means I will add only 1 gram of polymer into 10 milliliters of ethanol. So right now I have 1 gram of polyvinyl butyral polymer. I'm adding it into my glass tube container here, and then what I need to prepare is ethanol. First I will take some amount here, and next I need to measure 10 milliliters of ethanol. Alright, 10 milliliters of ethanol, be pouring it onto my polymer. So now it is ready to mix. We have a magnetic bar. This magnetic bar will help me to stir completely and dissolve the polymer here with the help of magnetic stirrer. We can completely dissolve our polymer solution. This mixture will stay here onto magnetic stirrer for 2 and 3 hours, and after 2 and 3 hours polymer solutions will be ready. Polyvinyl butyral solution just dissolved in 2 hours. So this is ready for nanofibers preparation. You can see. So join me into electrospinning process. So our polyvinyl butyral polymer solution is ready for electrospinning. We are at the laboratory of Technical University of Liberec. Right now we are nearby a laboratory scale nanofibers preparation device. It's called rod electrospinning. With this technology, we can quickly understand the prepared polymer solution is good for large-scale production or not. Right now, I will demonstrate a quick preparation of nanofibers by using our polyvinyl butyral polymer solution. There are 3 components in this device. Here, first one is collector, the second one is polymer solution reservoir with the shape of the rod, and the third one is the high voltage electric supplier. The high voltage electric supplier is connected to the rod, metal rod here from the bottom, And when we turn on the high voltage supplier, it will give the high voltage to our polymer droplets and it will start to produce our first nanofibers. As I said, safety first, so we use our chemical resistance gloves, we have the white lab coat, and then what we need, of course, the protective goggles. Alright, so the next things that we are going to do, use our polybutyral polymer solution. High voltage supplier on. We will control how many kilovolts of voltage that we are going to apply, which is written here 28. 28 is too much over there, so we would like to decrease a little bit, around 20. And then the second parameter is, which is important here, distance between electrode. Here we have a laboratory size electrospinning device, therefore the distance between these two electrodes shouldn't be so much. So the best distance between electrode is around 10 to 20. Right now we have 15 centimeters distance between the electrode, okay? The first electrode and the second electrode, it is collector. But we will collect all these nanofibers onto some substrate, which is here we are using silicone paper, okay? So by using easily magnet, we will attach this silicone paper onto our surface, collector surface, where the nanofiber will be deposited, okay? So I will just take small droplet of polymer solution and pour on the surface on the tip of the metal rod. So when I turn on the power supplier, nanofiber start to spin from the surface of the polymer droplets, and all the nanofibers now transfer to the collector, and on the collector they collect on a dry polymeric nanofibers layer. After we obtain sufficient amount of nanofibers on the surface of our silicone paper, we can take it from the surface. You see, these are our first nanofibers layer from the polybutyral nanofiber. Next stage is characterizations of these nanofibers. What are we going to do? We will use some microscope, but these microscopes are special microscope which can detect super small and tiny details from the nanofibers, because these look like a normal fiber, but scanning electron microscope can detect even tiny morphology, which means the structures of these nanofiber. They are good or bad. Let's go to another laboratory, start to characterize our first nanofibers. Now we have prepared our nanofibers, and I cut just a small piece of our nanofibers from the silicone paper. Now we will prepare this nanofiber for the characterizations. Therefore, I'm cutting a small piece of our polybutyral nanofibers and placing it onto a sample holder, microscope holder, adjust it properly and put it inside. Our sample is ready in scanning electron microscope. We just click to bigger magnification button, and now the microscope is getting as much as closer to our sample. Now we are 12,000 times closer to our first nanofiber membrane. We just need to make small adjustment to see as good as possible. That means just focusing on the surface of our nanofiber layer, we are able to see our first polybutyral nanofibers. If I want, I can even get closer, like 20,000 times, 30,000 times. If I want, I can measure the thickness of each single nanofiber. This is around 360 nanometer. This one over here, 261 nanometer. One over there is around 461 nanometer. I can go somewhere else. I see even thinner behind. For instance, this one, it's around 131 nanometer. And this one over here, the tiny one, is around 114 nanometer. So this is how we understand after the electrospinning process what quality of our nanofibers. I would like to thank to Digi-Mat project giving this opportunity to us and share the informations to engineering teachers and the students. I hope you learned something new today. I enjoyed a lot. I hope you share the same feeling with me. See you in the next project. Until then, take care.